Hello, everyone. My name is Luca. I'm an engineer with Man Group, and I'm speaking to you today from beautiful central London. So today we're going to go through this presentation about how Man Group is adopting DataHub for data discovery in the modern financial services space. So quickly, the agenda for today, we're going to go over what I hope you will get out of this presentation. After that, I'm going to tell you a little bit about an overview of Man Group, who we are and what we do. Then we're going to look at our data ecosystem. Following that, we're going to go through our search for a data cataloging solution. And then, spoiler alert, after landing on DataHub, our DataHub journey. And then finally, we're going to wrap up with some key takeaways. So without further ado, let's jump straight in. So what do I hope that you'll get out of this presentation? Why should you listen to me for the next 10 minutes? I hope that if you do so, I'm going to equip you with the knowledge that you're going to need in order to answer the next couple of questions for yourself. Why do you need the data catalog in the first place? Assuming that you need the data catalog, should you build one? Should you buy one? Or maybe you should consider a third option, so using an open source solution like DataHub. What are the trade-offs between those different options? And then, assuming you end up going with DataHub, what sort of shortcuts can you take to essentially accelerate your journey, or rather, which pitfalls might you avoid to make your life easier? A little bit about Man Group. So Man Group is a global active investment management firm. What do we mean by that is we're focused on essentially creating alpha for our clients to our different business units. Our main business units are the systematic, discretionary, and solution units. So when we say systematic, what we mean is that there's essentially an algorithm making a trade decision. When we say discretionary, we mean that there's a person making a trade decision for our assets. And by solution offerings, essentially what we mean is more advanced investment products that span the two. That's what we're looking at. And if you think about it, all of these different business units, they're underpinned by data, lots and lots of data. So looking at our data ecosystem a little bit, we've talked about a few of the different business units, but there's also other business functions like data engineering, risk, or trade execution, which underpin all of those different business units. And in each one of them, we have different stakeholders that I would broadly describe as data-hungry, diverse people that look at data in different ways. They use essentially different tools. They have different expectations of the data, right? And they understand it in different ways. So for example, a researcher, person who might be looking at building quantitative models based on the data. On the other side, you have someone like an engineer like me, or maybe a data steward. So someone who's very intimate with the data and is also responsible for knowing a lot about the data. In terms of data categories, so I'm going to focus on two main categories. Obviously, we have internal data, but in a way where we differ a little bit from other companies which might be looking at implementing DataHub, we actually deal a lot with vendor data. So what we mean by vendor data is we go to data vendors, we peruse their data offerings, we pick out data sets that we like, and we license them, we pay for them, we bring them internally, and then we build models on top of those data sets. Now, obviously, all of these different data sets and all of this data flying around is built on top of an infrastructure, a stack. We have a lot of Python engineers in the building, but we also have a couple of C# and Java teams. We actually built our own ETL, so extract, transform, and load framework on top of Python. For orchestration, we mainly use Airflow. Most of our services are deployed via Kubernetes. And this is the place where our stack differs a bit from most companies. In terms of database offerings, we actually use a database that we build internally called ArcticDB. Now, probably you haven't heard about ArcticDB before, so quickly let me tell you a little bit about it. As I just said, we built it internally. It's C++ based. It's essentially an S3-backed serverless database in which data frames are the main object. So what do I mean by that? If you've ever worked with data in any meaningful sense in Python, you probably work with a data frame, whether it was like a pandas data frame or Polar's data frame, doesn't really matter. But if you did that, you know that data frames aren't really the same things as, for example, a SQL table. In ArcticDB, if you go to ArcticDB to ask for some data, you're probably going to get it in a data frame format directly. It's also open source. If you'd like to learn more about it, there's a couple of links that you can follow and learn more for yourself. Okay, so we have all of this data in the company. You have different shapes of data, different requirements. And it's also important to know that it's always changing, right? We're getting new data sets. licensed, and so on and so forth. So we need a way to keep track of all of this data. We need essentially to be able to search for it effectively, to permission it, to figure out what its licensing status is, all of those things. In order to achieve those or satisfy those requirements, we built our own catalog, which is called the Codex Data Catalog. I'm actually part of the Codex Data Platform team, as it so happens. It's very well suited to our man group specific needs, for example, modeling data vendors that I mentioned before, or modeling the licensing status for a particular data set. And it really has good search capabilities as well. So it's useful when you want to go and search for particular data sets. Let me just show you. This is roughly how it looks. But given that, it has a couple of limitations. So what do I mean by that? For example, we'd really like to be able to use our data catalog to search for upstream data sets or upstream data pipelines. So if there's an issue with a particular downstream data set, we want to really quickly figure out whether that's coming from upstream. Maybe there's a file missing from a vendor or something like that. And that's quite difficult to do as is. Besides that, we'd like to essentially broaden our customer base for our internal catalog. So we want to show it to more teams and to get as many teams as possible on board with it. So given these limitations, we thought, maybe it would be good to go out in the world and see whether there's any good solutions on the market, any existing solution. So that's what we did. On this slide, we're comparing DataHub, sort of like an hypothetical competitor, because after looking at many of them, actually, they were quite similar in their offering. And two criteria that I want to focus on, the two most important criteria for us were whether it was on-prem deployable. So this is due to the nature of our financial services business and due to the way our infrastructure is set up, this was non-negotiable really. And obviously because we're so focused on RTDB, we had to be able to build RTDB support into it. Now, given RTDB is built in-house, we didn't expect any catalog to have it from the get-go, but we had to be able to build it. And to be frank, none of the other catalogs that we looked at really had any of those two features. So DataHub, big plus in this regard. But we were looking for some other features as well. So for example, we want to scrape metadata from RTDB, but we also want to be able to gather metadata, so push metadata into DataHub from different sources, not only scraping. So that was very important for us as well. And as mentioned, having some sort of data vendor model is great. It is quite niche, so it wasn't really modeled, but we're hoping to build it ourselves. This slide sort of illustrates why we went out and built a POC of DataHub internally. So how did that go? Honestly, it's going quite well. We're currently at, we're currently at the stage where we're pushing DataHub to the different environments that we have internally. We've built essentially a custom Python client that allows us to take our internal metadata model and change it into a model that's compatible with DataHub and then emit it. And we're sort of iterating on the shape of that model. We're presenting DataHub to different users. We're asking them for feedback, and we're trying to action that feedback. So some interesting findings from me at this stage. If you do end up doing like a demo or toy deployment of DataHub, I'd recommend you do it with a small unsecured Kafka cluster. You can try to secure it, but it might be a bit of a hassle. Also, if your organization has Kerberos authentication internally, you can try to use that for the different infrastructure components, so like Kafka or the database, but that can also be a bit of a pain. And actually, at this stage, it might be worth noting the fact that if you use something like DataHub Cloud, so a software as a service solution, you wouldn't have to deal with any of these deployment issues. Next up, if you do use the data products, they're actually quite neat, but it would be better if you stick to a relatively low number of assets. If you have too many assets in a data product, then it ends up creating really large messages on Kafka. And we've managed to merge already a PR to DataHub, like one of the new contributors that was on a couple of slides ago is from Man Group, so that's great. And it was relatively straightforward. We found the process relatively low friction, so good job there. Moving on, okay, now that we're at the stage where we're sort of getting DataHub into production, where do we see DataHub providing business value practically? I'm going to give you a couple of examples. So first of all, we see it being used heavily, or foresee it being used heavily by our data stewardship team. It's essentially a tool that they're planning to use to, as I said, navigate the lineage of a particular data set, see whether an issue is in a particular upstream data pipeline, or even more upstream from us in a file, or maybe there was a file missing delivery, that sort of thing. Besides that, we're hoping that it's going to improve search and discoverability by essentially providing a slightly different mental model about how our data is structured and how the hierarchy of data works. And by things like tagging and terming and having access to hierarchy tools like domains and data products, we're hoping it's going to improve essentially our governance structure, plus things like business owners, so being able to say who owns what and in what way and who should be contacted, that sort of thing. Okay, so let's wrap up. A couple of key takeaways. If you go and build your own metadata model, I'd say it's better to do it iteratively. So start small. Maybe you just need a couple of DataHub entities. Maybe just start off with like domains, data products, and datasets, of course, and build those out. And then you can look at the plethora of entities that are available, get familiar with them, get accustomed to them, and maybe some of them aren't really of much use to you, and that's fine. There's so many of them. You're surely going to find some that are a good fit for your company, for your organization. You can build those out. Again, as mentioned before, probably try to avoid overloading data products. And on the build versus buy question, it might be that open source is actually quite a good compromise. It should be a lower cost than just buying outright, and it should give you a lot of the flexibility of building. However, there's no free lunch. You're still going to need an engineering team that is going to deploy it for you and look after it. And that's going to take time, obviously. A couple of things on our wish list, so things that would make our DataHub experience a bit better. Obviously, as mentioned before, a data vendor model, although realistically, we're probably going to be looking at building it ourselves, and maybe if there's appetite for it, upstreaming it, I don't know. Some improvements for the lineage UI and the SQL ingestion source would be nice. SLA UI, so what do I mean by this? Essentially for a particular data set, if you'd be able to see that it's supposed to be updated at a particular point in time, and if it misses that update time, we should get an alert or notification, that sort of thing. And we've heard a couple of companies sort of toying with the idea of a logical or virtual data set. So from the point of view of the data consumer, you shouldn't have to worry about whether it's on a particular cluster or environment. You just want the data, right? Whereas an engineer or someone more technical would need those details. So essentially different views in terms of what is the actual source of truth for the data, as it were. But yeah, thank you so much for listening to this presentation. If you want to reach out, there's some contact details on the left. And I'd just like to call out the fact that we're running a London hackathon. It's going to be on the 9th of November in London, obviously. We're going to be working with a couple of charitable partners. So we're essentially going to be trying to improve their data stack. And there's going to be open source contributors from major projects, which you've probably heard of attending, like Airflow, Fast API, and Pandas. So yeah, if you're interested, the link is on the slide. Thank you so much for listening.